Then hello from me, Stefan, Yatka, and Tilman. So to introduce us, Tilman and I, we are researchers at the FU Berlin, and Yatka, as you all know, at SAP, and we created this MOOC together, which is called Exploring the World of AI. And in this talk today, we want to give you an overview to show you what we've thought of about doing in our MOOC, how it is like set up, and what students or people interested in all this stuff of AI should know, should learn, should do, and so on. And to get started, I want to get us all in the mood of what is AI, what are we talking about, and you all know those examples. We have those, stuff like natural language processing, which is about the understanding of spoken languages, and this is one of the examples, like with Alexa, that we see in the bottom left corner, like this subfield of AI. We all know this movie recommendations from Netflix and Amazon, where AI is used to make better recommendations based on what we bought, what we watched, and so on. And smart mobility, that's another thing, also controversial use case of AI, with the rise of self-driving cars, produces many questions, like who's responsible if the AI fails? And of course, we all know those games like chess and Go, which we see in the top left corner, that is really famous for a use case of AI, which is explored by a lot of companies. And with all of this, our goal of AI education is to enable people to participate in this increasingly digital world, so that they are consciously, by using this AI technology, and see how it affects them personally. And that's not the only thing. Furthermore, they should also get involved in shaping this world, designing how we interact with AI, how AI is shaping our world, and that they have a foundational knowledge about AI that enables them to not only use all those applications of artificial intelligence, but also to design and create their own AI solutions. And with this increasingly important debate about like where we apply AI, which is also or creates ethical questions, the goal is also to allow all students, all persons, all learners to make informed decisions about AI in society. And I think we're all clear about those points. But the more interesting questions is not whether or not we should teach AI, because we are all on that same boat that we want to teach it. The more interesting question is what to teach, and which topics are relevant for students to learn in terms of AI, regardless of if they will become computer scientists or not. And the knowledge that is required for their future, for example, to make those informed decisions or to create all that stuff. And we have a simple thought experiment for you. Please try to remember the alphabet that we have provided on this slide for you. And we'll give you 30 seconds for that, and screenshots are not allowed, sorry. 30 seconds are running. Okay, time's up. I'm pretty sure you can all tell me what those numbers mean. Probably someone wants to try it in the chat. Someone who hasn't taken a screenshot. Can someone translate those 4 symbols into numbers? Yeah, Ben, I've forgotten them all. It's not your fault. It's pretty difficult, but the last one was 7 indeed. As we are a little bit nerdy, we choose 1337. 211 was pretty close, but yeah. You may find this task extremely difficult, and so do I, and so do Tilman, and so do Yadga. And you might wonder, why on earth we wanted you to learn all of that? And yeah, well, the answer is we didn't want you to learn that, but we want to show you that there is a simple idea behind it. It's actually the encoding inspired by the dial keys of a telephone. So the 1 is encoded as a border to the bottom and to the right. The 5 is a complete square. The 8 is surrounded by borders everywhere except the bottom. So you get the idea. And if we made you learn this underlying principle instead of this full encoding table, you would have been able to decode 1337 much easier, I think. And in fact, you might have recalled this underlying principle, this encoding, for the rest of your life. But it's not about the encoding here. It's about what we can learn from this experiment, from this thought experiment. So in teaching AI, we need to focus on those underlying ideas as well, not just those applications that we presented on the slide before, like NLP with some Alexa stuff, self-driving cars, and so on. So for AI education, this means that we should favor the underlying principles, such as how machines can learn, rather than just the usage and application of certain frameworks that can be complicated as PyTorch or TensorFlow, but also like something we create for Snap or so. Furthermore, it is more important to let students create personally meaningful artifacts, as the students learn best while being creative and pursuing their own goals instead of using predefined models for somewhat artificial projects that we put in those encoding that we just showed you. And in addition, only a look at those underlying principles will enable all students to discuss the topic of AI in a differentiated and conscious manner, as opposed to being part of one-sided debate by either solely focusing on hyping the potential or by exaggerating the societal risks of AI. And that's the principles we aligned our MOOC to. And this is like the cover slide of Exploring the World of AI MOOC. And this MOOC is actually intended for people that are interested in AI without a CS background. So there is no focus on a specific grade or something. It's just all people, no CS background, interested in AI. And of course, for teachers who want to teach AI. So this course is not for some experienced coders looking for a technical introduction or about some specific framework. And now it comes to the most interesting part, the journey. So you might have seen it. We used all those planet stuff to make it a little more interesting. And the journey is a journey to a lot of different planets. And in our first week, which is like the first row, we answer a question like, what is AI? What is actually machine learning? And what's the difference to other approaches to AI? And in this first week, we use reinforcement learning. This was a decision we made. Tilman will tell you more about what happens in those specific units later. In our second week, it's all about the other machine learning paradigms and their underlying principles, of course. So we take a look at supervised learning and unsupervised learning. Did I get stuck? No, it's working, okay. And our third week is about the bigger and sometimes smaller picture with questions like, can machines really think? What are those famous neural networks? And what the heck is doing AI with society? And now I'm over with this part and want to hand over to Tilman, which will walk you in detail through this interesting and incredible journey.
Exactly. You were not stuck, but you showed us how UDP works, I guess. So I will take you on a kind of short version of our full journey of the MOOC. So in the first planetary stop, we explore how media and culture influence our conceptions of AI, like the pictures you can see here, how AI already influences our daily lives, and based on a short history of AI, investigate and discuss different definitions for AI and how the increasing computing power as well as the digital transformation are the reasons that AI and in particular machine learning are like the hot topics of the last few years. And building upon this, we distinguish between learning and a traditional symbolic approach to AI, using the context of chess, or more precisely, as you can see here in the small picture, a mini version of chess. First of all, we play an unplugged game to learn how an agent can learn to play chess over time by gradually improving its strategy using M&Ms. And this way, we conceptualize the idea of reinforcement learning as one way how machines can learn, which is visualized by the sweet robot you can see in the bottom right, who's trying to plant some flowers. So reinforcement learning conceptually consists of 4 steps. First of all, capturing the state of the environment. In this case, how big the plant already has grown. Then choosing an action, such as watering seedlings or taking the spade and planting seeds. And depending on the following state of the environment, receive a reward or punishment. Here our robot gets some coins. And this way the agent learns to optimize its strategy based on the reward he received for a certain action in a certain state. So in our example, the robot learns that watering the seedlings seems like a better action for the state seedlings are already planted than using the spade to pull them back out and plant some new seeds. So this is what we mean by we want to focus on those underlying or fundamental ideas. This is the underlying idea of reinforcement learning, and we use this unplugged game, which we have in a digital version. We have an applet for this for the participants of the MOOC, so they can do the same thing at home. And in the next video, we use Snap, as we presented it last year on SnapCon in Heidelberg, to actually implement those 4 steps for an agent for the simple banana hand game, where the monkey learns to play over time using reinforcement learning, how to jump over the barrel. As well as, and we do the same thing for the game Pong. And for this, we use pure Snap. So we have no JavaScript, no external libraries, and so on. All the magic is happening in Snap itself. And this way we can actually look behind the scenes and see and experiment with how this magic machine learning actually works. Afterwards, we play another version of our unplugged mini chess using a traditional or symbolic approach to AI. And this way learn, first of all, what makes symbolic AI symbolic in the first place, and what expert systems as one approach to symbolic AI are. For example, by helping us not to mix some ingredients, which we shouldn't mix. And by having those 2 versions of mini chess, the learning one and the symbolic one, we can compare those 2 approaches to AI and investigate the complexity of a mini chess, and for example, the famous game of Go, and why, for example, the symbolic AI Deep Blue, which beat Kasparov in chess famously in 1996, was not able to compete in the way more complex game of Go, which was beaten like some years ago by machine learning and AlphaGo. In the next week, we learn about 2 other ways that machines can learn. First of all, supervised learning. And once more, we first of all play an unplugged game, which I have prepared in the slides for you, and we will now play together. So we are zookeepers, and we want to know which of the monkeys bite when we are feeding them and which do not. For some of our monkeys, we already know that. you can see on the left, the monkeys we know that will bite us if we would try to feed them. On the right, those who won't bite us. And it's now your task to set up rules based on these monkeys, which help us to distinguish whether when a new monkey arrives at the zoo, so that we can know if it does bite or if he does not bite. So you can focus, for example, on these features of the different monkeys, like whether they have their eyes opened or they're showing their tongue, and so on. So this is now your task. Figure out rules based on these monkeys that says which monkeys are biting and which monkeys are non-biting. And of course, you can use the chat to share your ideas. All right, there were like a few rather good ideas in the chat as far as I can see that. Now I have prepared some new monkeys arriving to the zoo, such as this one. According to your rules, does the monkey bite or does it not bite? You can vote by putting your hand up, for example, using the Zoom feature, or like in real life. Now, it seems that most people agree on it not be biting. And you're actually correct. This monkey does not bite. How about this one? Okay. I think the majority agrees that this monkey is biting. And yes, we should be careful when feeding him. And I have one last monkey prepared for you. And once more, the majority seems to agree that this monkey is not biting. Let's have a look. Yeah, you're right. Great. I think most of you got the idea and how the rules work. What I will not tell you in this moment, what are the correct rules, because you should be interested in the MOOC itself, of course. Actually, we use and introduce at this point of time decision trees as a solution for this problem, which we now do not have the time for. But I think most of your rules look pretty good. Yeah, and once more, we use this game to learn about the idea of supervised learning. What's more visualized by our robot. We have a lot of labeled data. So for monkeys, we know whether they are biting or non-biting. Then we find a pattern in this data to match the input and the label, such as you did with the rules. And then we can use this pattern, this model, as we would call it, on new data, such as the new monkeys we had to, and apply it and see whether it works or whether it works not. And once more, we actually implement this supervised learning in Snap with decision trees to distinguish biting and non-biting monkeys for a lot larger data set using decision trees. Yeah. And as I see it, I took a German screenshot instead of the English one. In the next video, we learn about the third or final way machines can learn, unsupervised learning. Once more, we use an unplugged game where we want to get rich. This time we want to get rich by finding a lot of gold in the Wild West and have to design an algorithm on how to use the coins you can see in the picture and the series of reports of gold findings. And as before, we have an applet for the participants of the MOOC so they can do this online and then compare their approach to the approach we show in the video. And once more, we use this game to conceptualize the underlying principle of unsupervised learning, where we now have unlabeled data, this time the gold findings, and find similarities to eventually identify clusters and exceptions, which probably makes a lot more sense if we would have played this game in before. And once more, as you might have guessed, we implement this algorithm in Snap, and as we see the algorithm working in Snap, we identify some problems with the very basic algorithm and make improvements based on the observations we make when the program is running. For the last week, we focus on a few more interesting concepts in the context of AI. First of all, we use the famous Chinese room experiment to reflect on the question whether machines can actually think. We chat with the chatbot, and we apply the Turing test and learn about the history of this. In the next stop of the journey, we investigate the concept of a neural network, and how neural networks work, for example, to distinguish between a vegetable and a fruit, and actively experiment with the parameters of such a neural network in Desmos, which is a tool you might know from math education. So there you can once more actively experiment and learn about the process of adjusting parameters for a neural network. And of course, we focus on the important topic of AI and its influence on our society. To this end, we talk about fairness and bias, and based on the knowledge we now, after visiting all those planets, have, investigate the phenomenon of how AI makes discriminating decisions that are reported in the media. So we learn that based on the bias we humans and our data have, AI and artificial intelligence learns this bias and applies it in their decisions. And furthermore, we discuss the idea of transparency in AI's decisions, in particular to see those bias, to identify such a bias, and how explainability and the idea of explainable AI is important for the usage of AI in our society. And based on the probably famous example of the stop sign and how it is interpreted by an autonomous car, this one, I think, is 80 miles per hour for a rather simple autonomous car. We talk about security in the context of AI and the decisions that influence our society. And last but not least, we have a video just for educators where we provide further information regarding AI education as a whole and potential further great resources to use in the classroom, such as Orange 3, eCraft to Learn, or machine learning for kids. So to come back to our design principles, the important factors in the design of this MOOC. this way, we achieve our goals of AI education. We focus on the underlying fundamental ideas of AI and machine learning, such as those visualized by the robots or the differences between symbolic and learning approaches to AI. And Snap enables us to actually build our own AI and ML artifacts without any or that much programming experience, which we can use to enhance our games, for example, by adding an AI or analyzing data. And based on this understanding, we have a differentiated discussion regarding the influence of AI and our society, such as fairness, why there are problems with bias, why transparency and explainability are important, and the security of decisions that are made by an AI. So thank you for this short version of our journey through the world of AI. The MOOC itself will be available for free at OpenSIP in October 2020, most probably, and as Stefan, I think, already said, in English as well in German language.
And if there are any questions, we are glad to answer them here.
Yeah, I have a question, which is, I like the overall design of the course, but my own personal taste would be to interleave more of the different pieces so that you don't leave to just the last week things like AI and society or can machines think, but that as sort of topics come up, you try to connect them up with the bigger picture and not do it in this sequential way. So I'm just wondering how much you thought about the same material, but interleaving some of the pieces. So
that's a very good question.
That's the big picture.
Yeah, that's a very good question. So you're totally right. This is very important. We try to do that as much as possible. So we reuse our examples from, for example, supervised learning in the aspects of the neural networks. So we use the exactly same materials and examples, the same way we do this in the AI and society part, where we once more reflect on the examples we saw before. So for example, the game with the monkeys you just played, the solution for this is a decision tree. And then we present a crocodile. And based on the rules we just had, the question is this animal biting or non-biting? And actually, according to the decision tree, the crocodile would be, or based on the features, would be non-biting. So this is one way we try to interleave those aspects so that we use the examples where we learned about more the technical perspective, how things are working, and reuse them to see on the ethical implications.
Good.
More questions?
I have a short question. Did you try these libraries in Snap 6? And if so, did you get any speed improvements?
Actually, not yet. We were very hyped to see Snap 6. We expect massive speed up because, like, I think we started with all this before Snap 5 actually, and this was like a massive boost in speed. So we are happy to try it out with Snap 6 as soon as possible, and we are pretty sure that there are a lot of more cool things and ideas you can do with Snap 6 in this data context. So we are pretty hyped.
There is another question in the chat that's saying,
how long
does the MOOC take? And the MOOC is each week. So when approximately less than 1 hour a day, so it's pretty convenient to take, I think.
So maybe I'll just repeat it because I think your internet would be was not the best. It's 3 weeks, and we have 4 videos a week, about 15 minutes each video, and some extra exercises. So if you only watch all the videos, it's about just 3 hours actually. So you probably can use it in school and stuff like this. One more question.
I hate to cut
sorry?
it short, but I think that we have another speaker for this time. So if you have any other questions, I think you can follow up by email, just because we're out of time right now.
Yes, of course. Email, Twitter, whatever. Or the forum. Very good point.
Or use the forum.
Okay, then thank you very much. We're happy to answer more questions, and we're happy to get feedback in October.